Hey everyone, welcome back. So we're going to look at another exercise in Watkins. It's 1.25. But as mentioned before, these proofs or these exercises can be found in other linear algebra books as well. And this one we're going to prove that if the inverse of a matrix exists, the determinant of that matrix cannot be zero. There's several ways to prove this. I'm going to prove this one directly by assuming that A inverse exists, and then showing that the determinant of A cannot be zero. We're going to need to use a rule, a property, and that is that the determinant of the product is equal to the product of the determinants. So it looks like this. So if you have A times B and you take the determinant, that is the same as the determinant of A times the determinant of B. We're going to use this property. All right, so we're going to start the proof. We're going to assume that A inverse exists. So proof A inverse exists. If A inverse exists, then we know that A times A negative 1 or inverse is equal to the identity, or similarly, actually they're actually the same as the property of the inverse, and A inverse times A is equal to identity. For shorthand notation, you might see it like this in a book, like we'll just put them all together. Right, so we're going to use that property. Since the inverse exists, we can assume that this is also true. So let's write that down. We have A times its inverse is equal to the identity. That is true, and we can use this because we assume that the inverse exists. Now what we want to do here is take the determinant, both sides. So we're going to do determinant of A times its inverse is equal to the determinant of I, of the identity. Now the determinant of the identity is just 1, so let's take care of that at this moment. That's just 1. But here we have the product. We have the determinant of the product, so we can split that up using the property mentioned above. So let's split those up, and we would end up with the following. We would have the determinant of A times the determinant of A inverse. And here we almost finished. We have to think about it for a second. We have the product of two elements, and it's equal to 1. So the only A cannot be 0. If the determinant of A were 0, if this was 0, then whatever this is should equal 0. But we don't have that. Right? What we have is that it's equal to 1. So there is no way that the determinant of A can be 0. If it were 0, then this result here would be a 0. But since it's not, then we can assume that the determinant of A is not equal to 0. So we could just say, thus, determinant of A is not equal to 0. We don't know what it is, we just know that it's not 0. And that's all we needed to prove. Again, so this proof is complete. Please try it out on your own again for more practice and understanding. And if you found this video helpful, please give it a like and subscribe, and I'll see you next time.